I would like to present you Sitech services. And a special department in our company is the Asset Health Center. We have different departments. We have one department, technology and innovation. There we have several skill pools: reliability engineering, static engineering, rotating engineering, electrical instrumentation, all these. And there's one department in that is Asset Health Center who's working with big data. I'm a representative of Sitech this evening, and I want to introduce you to this Asset Health Center. This department specializes in data analytics, where we offer various products to make our customers even more competitive through AI and data-driven optimizations. We are a service provider, and we help our customers to get more out of their factories. What does this mean? We offer two kinds of products, and namely our standard. Our standard condition-based monitoring service and tailor-made process analysis to optimize process production. With our process analysis, we help customers optimize the production processes, such as raw material optimization and output optimization. In concrete terms, we look for deviations in both products and enabling engineers, technologists, and maintenance to make better choices based on substantiated data. Our team has over 5+ years of experience with Industry 4.0 and more than 30 years in preventive and predictive maintenance. Yeah, what challenges do we have now with Industry 4.0? In the industrial sector, more and more components are being linked together to exchange data and to automatically adjust the control of machines and processes. That brings both opportunities and challenges. Many of these challenges have to do with cybersecurity and process management, but many challenges also have effect on people and the wide variety of providers on the market. Within the Sitech Asset Health Center and the products for our customers, we use the latest cybersecurity standards and process to tackle the technical challenges. In addition, we guide customers according to an Industry 4.0 standard to make the change as easy as possible. What makes Sitech so special is we are OEM independent. So we can choose the best sensor on the market, choose the best software, combine these, and make a solution for our clients. That means the data we get from our clients are process data, IP21, vibration monitoring, wall thickness measurements, corrosion under insulations. All these data comes together in our system, also from SAP. And so we have numerous measurement points in the plant and can also make a complete digital copy of the production unit. What do our customers want? They want to decrease downtime, just as with Saudi Aramco, it's the same everywhere. We want to derive new value from data. We are losing our most experienced technicians. A lot of people are retiring and there are not enough engineers on the market. So what we are using with our artificial intelligence is our old school technicians and engineers. They put their wisdom in algorithms so that in the future our computer can help with 80% of the problems we have. So the knowledge will embed it in our digital data bank. What we have seen so far is that with artificial intelligence, the benefits we've gained is that we have a reduction of operational cost. We will see in the further examples that we can reduce maintenance cost and production cost by using AI, which gives advice, shows you anomalies in your factory, and prevent your factory from shutting down. We see that we reduce maintenance cost. It's also foreseen in the example we show, and an improvement of the performance and OE. If you can prevent that the plant has to shut down for cleaning examples, your uptime will automatically go higher and higher. How we do that? How do we do that compared to the early days? In the beginning, we had the FMEAs. A few years ago, we were doing FMEAs. What can go wrong on that pump? What is the root cause and things like that? Today, we have the data of the pump. We know the temperature of the liquid, the fluid, how fast it goes, the pressure, the speed of the pump, vibration analysis. And all this data comes together in our UltraGrid network. First, what we have to do is data cleaning. There are two things we have to do. Is you have to get rid out of the events, which doesn't matter. Start, stop. If everything is in stop stand, we are not interested in that data, so that will be skipped out of it. We're also looking to variance. Some of the measuring points are giving the same value for half a year. So that will not be important for our analytics, and we throw them out. After that, we go to the future grid. Data is cleaned, then we go to a feature grid. In a feature grid, there are all the FMEAs translated into an algorithm. So we are applying their business logic or statistical knowledge. And it's a selection of features which we are going to use for our model. Is it a pump or is it a heat exchangers, depending on that. After that, it's based on FMEA or on statistical knowledge. We start with a modeling grid. A modeling grid, there we test a large array of algorithms, about a few thousand algorithms. We let loose on all the data and see if we can get information which is useful to predict something, or if it's useful for what we are looking for. On these algorithms, you have some small hyperparameters, they call them, and you can adjust this algorithm, fine-tune it. If you have some result that you get back, that you get more result. And based on this exercise, you will end up with about 50 algorithms. So you start with 2000. After this exercise, you end up with 50 algorithms, which can give the most useful results. With that 50 algorithms, we do a validation exercise. You have an internal validation and an external. The internal validation is done with the data that you use to learn your machine. So you name a certain period, you use it to learning the machine, and you see if it gets the good result. If it's validated for that, and then you go, next step is external data, external validation. That means you get new data you didn't learn with, put it again in that algorithm and see if the outcome is what you're looking for. After this screening, you end up with mostly 3 algorithms which give you a result in finding the correct direction. We call that the model selection with the 3, and then we deploy it. And in deployment, we start using real data and sending it to the algorithm, and to then here for when it finds an anomaly and gives us a ring or a pop-up if there's something going on. Please have a look at it. show you something, an example of preventive maintenance. The preventive maintenance is still like the old way. You have the FMEA, you have to know what you're looking for, and you put the data on it. And you will see here, you can see we have a temperature measurement inside the motor we are monitoring. Can you go one back? Yeah, thank you. You have the temperature. As soon as the temperature was rising, this was a customer who had a motor failure several times on his plant. And he asked us, can you monitor it? And can you predict when it's going to fail? So it's, they're in the salt business. And we put some monitoring on the motor. And after a few weeks, the temperature of the windings was raising. So we warned them there's something wrong. We don't know what, but your motor is getting overheated internally, and it will, at this rate, it will die in the future. So when they stopped, and you can see it here on the there's a little salt particle on the winding, and that causes corona. And that damages your insulation of the motor, and that's why you get short-circuited and the heat goes up. So with this failure, they could go back to the OEM who supplied the motor, showed them, and it was in the specification where they were going to use it, and had some warranty case with the supplier that their motor wasn't according to spec for this application. So that will prevented the plant from shutdown because they know they had a problem. So you go in a planned shutdown instead of an unplanned shutdown. That will save you money and also prevent some other problems. But it's still the preventive and predictive maintenance thing. What we are more interested in, and what we also use in RBI, is next step, is prescriptive maintenance. We had a heat exchanger fouling, and a customer asked us, The customer asked us, can you find a sweet spot? When do I have to clean this heat exchanger? Before it's full too much and have to reduce production, can you predict when I have to clean it? Yeah, it's possible. We can and use the data you've got at the moment. It is not in the scope to add some additional measurements, because in the heat exchangers, the most interesting thing is temperature in, temperature out, and flow. Then you know directly everything. This was not available for us. There was no measurement of the temperature in, temperature out, no flow indication. They gave us a delta P, and they gave us a speed of the liquid. And with that, thanks to engineering, they also know which part you need and where. So what we did, we built a model of this. And here you can see the blue data points are the threshold values where you give the command you have to clean the heat exchanger. The darker the data, the white and the red ones are the measuring points, and the brighter the point, the more recent the value is. So what you see is after cleaning, you have the orange and the red points is before cleaning. After cleaning, the values are much lower. So as soon as you hit the blue one, in our prediction, we said it's time to clean it, you clean it, and then you lower it. So we found our way to predict something for the heat exchanger for our customer. While we were monitoring it, something weird happened. During a weekend, without cleaning, suddenly the heat exchanger was performing better than before the weekend. That's weird. Anomaly says this is not correct, wrong algorithm. Then we use the technology guys and the guys from Sitech. How can this happen? They say, there must be something wrong. We collect the data, we go over the data, look where the anomaly first triggered us. And at that time, we see that an operator made a small mistake and overpressurized and overflowed the heat exchanger. You can see it in the little orange bump. It's more visible. No. You see it here. You see it in the orange bump, and after that orange, the later data is brighter, is more at the bottom. It means your heat exchanger is more efficient. That was interesting for us. So we organized an experiment. We have a buffer tank available for that thing on site. We had lucky with that one, and we made sure that we could do this exercise again with a high pressure and high flow through the heat exchanger to get it cleaned again and to try if it works. So we did it again during a weekend, and what happened is in reality the heat exchangers performed much better afterwards. So with the data we gather, we know where it's time to clean, and before we cleaned it, it was taking it out of service, stopping the plant, taking it out of service, opening the heat exchanger. Then with high pressure water, it will be cleaned. Water has to be going to the water treatment area and all things and problems. So you have a lot of downtime, you have a lot of cleaning cost, you have the safety issues and all with that. With this, we could do some inline cleaning. That means no downtime for the plant anymore. The extra maintenance cost for cleaning and heat exchanger was scrapped from the budget. And we integrated this algorithm in the software. By using this, and that's interesting, is prescriptive maintenance. We now measure when the heat exchanger is a bad performer or is going to be a bad performer. With that knowledge, we can inline flush it, and you extend the lifetime of the use time of the heat exchanger. So in the previous, we showed you the optimum for between reactive and preventive maintenance, that the predictive is the optimum. What we've now seen is with prescriptive, when you can prescript how to use your equipment, that you can even lower your cost per ton produced. This methodology will save us per heat exchanger 10,000 euros per year, because the annual cost for a heat exchanger is here. It's every 3 years we do a cleaning, and it's cost you 41,000 euros in total. That means about 13,000 euros a year on average. With our data monitoring, it costs about 3,500 euros. So your gain is about 10,000 euros. No downtime, no extra maintenance. And what you can see in the previous slide is we have now a heat exchanger always working on maximum capacity. This learning on where the sweet spot is in your factory, we not only use for heat exchangers, we use it for RBI also. In the RBI studies, you have the operating window, your integrity window, where you have to be to have the maximum lifetime of your equipment. we now guide the operators in a funnel to maximize the lifetime, to minimize the cost of that plant. If the operator goes outside this funnel, there's an alarm triggered, or intelligence says something went not according what we wish. That goes back to a forum, we call it a PO, is a plant integrity overview, where the operators discuss this anomaly. Why did it happen? Why did you exceed this temperature? Why did you exceed this flow? If it's not damaged for the future of the plant, it will stay there, and they will give some recommendations to the operations how to prevent it in the future. If it causes a damage, it goes to the management overview. So then you have a management integrity meeting of a thing, what happened in the plant, what's damaged, and will cause an effect on the next turnaround or the next stop, because we have to inspect. If you stay within the funnel, we know what's going on with the equipment, we know what's going on with our integrity, with our production. If you go outside, we have to measure again and see how much damage you generated with this execution. For us, the knowledge of being in the right path is an advantage for operators. We help them to be better. We help them to keep their plant in the air, to have less problems. If you have less problems as an operator, you sleep better. We also have less problems with engineering with this thing. And also for the new guys, what the old guys know, we always put in the FMEAs, in the old FMEAs, failure modes, because we have learned a lot of things during the 40 or 50 years we maintain these factories. This is now embedded in the software and will help the next generation to be a better operator, to understand it, because we can link what is going on. That's my presentation.